Okay, Algebra 1. This is our lesson, 2.1. Starting the next chapter. So good. You need to write all this down, upload it when you're done to get credit. This is like a third of your points just for class today. So write the title, make sure you put your name. All right, make sure you put your period, put the date on the top of your page, like you would anything you're going to turn in, like you're turning this in class. 2.1, writing and graphing linear inequalities. At any point, you could pause the video to catch up, because you need to have all this down to get credit. Now, inequalities are less than, greater than. So let's start by just making like a little sort of a cheat sheet up here at the top. So these are inequality symbols. Let's talk about the inequality symbols. Now, make a little table here. So we'll start with this symbol. Now let's see. We'll get our table all ready. Break it up into fourths. Okay. All right, so we're going to do that symbol, this symbol, this symbol, and that symbol. So this is, back in Math 8, you guys learned these. You might have thought these symbols like an alligator or Pac-Man, which I think is, it's a good, helpful trick to remember. They want to eat the bigger things, right? Or I just think that this opens up. The bigger part of the symbol is going towards the bigger thing, and the smaller pointy side is going to the smaller thing. But this means is less than. But there are other ways to say the same thing. So let's write those down. Is fewer than is another way of saying that. Is fewer than. That means the thing here is less than the thing here. Okay, so you read it left to right. So this is greater than, or is more than. Okay, a couple different ways. Now, I always start with is. Is in previous chapter was just an equal sign. So is kind of starts the part that compares one side to another of an equation. This is less than or equal to, right? There's a couple other funny ways of saying this. You could say is at most. Is at most, which means it at the most. Like if I say I am at most 45 years old. Well, that means I could be 45, or it could be anything younger than 45. Or is no more than. So it's kind of like using the other way of saying, instead of saying less than, it's not more than. But then that means that actual value can work. Okay, is greater than is one way of saying that. Or equal to, which means the value can be used. Or you could say is at least I'm 20 years old. Well, is that less or more than 20? 20 at least means the youngest, the smallest number I could be. But I could be that. Is no less than. So there's a bunch of different ways we could write this, but that's we'll use this as like a little reference. This could help you on your homework. So let's do a few examples here. Number one, the directions, which you should write down here, would say something like, write the sentence as an inequality. Write the sentence as an inequality. Now, at any point, like I said, pause the video, finish writing this down. One of the benefits of distance learning. All right, so we're going to do a few different examples. So, A, the temperature in AG is at least 70 degrees. Okay, so on the homework, you need to write this down. This is the problem. You got to write the sentence down. Now we're looking for the keyword is at least. So I mean, it could be more than 70. Is 70 the smallest it could be, or is 70 the biggest it could be? At least 70 is the smallest. So it could be 70, 71, 72, right? If you go up here, you could also look for at least. It's going to be greater than or equal to, right? Now, let's create a variable because we're trying to write a math expression here. Let's use T for temperature. It's good to pick variables that kind of represent, more clearly what they are. The temperature is at least greater than or equal to 70 degrees. That's it. That's your answer. Let's do another one. The elevation of AG is at most 143 feet. So I'm giving you kind of some of the more weird ones. Is at most. A lot of times people get kind of tricked out. If it says less than or more, then it's a little easier. Is at most. Well, if it's at most 143 feet above sea level, does it mean it could be 144, 145? No, this is the most. So 142, 141, but could it be 143? Yes. So is at most, that's going to be less than or equal to. So I'm going to do E for elevation. The elevation is less than or equal to 143 feet. C, you are at least 14 years old. Now, the keyword is isn't here, but are. At least. Okay, so if you're at least 14, does that mean you're older than 14 or younger than 14? Possibly older than 14, but you could also be 14. So we could do Y for you greater than or equal to 14. Could be more than 14 or equal to 14. So that's one kind of problem you will do today. Number two, directions will say something like this. Tell whether -4 is a solution. Okay, and we'll do a couple examples here. X plus 8 is less than -3. So we were able to check answers in the last chapter also. And we're going to check it the same way. We're going to substitute the value in. So we're going to plug the value in. I always like to put it in parentheses the first time. So we just plug the number in for X, and then we simplify both sides if we need to. -4 plus 8 is +4. All right, keep going down. Now, when you finally get to a number and a number, you need to decide, is this a true statement? Right? So in your head, you're thinking, is this a true statement? Okay. Is 4 smaller than, less than -3? No. The answer is no. All right, let's try another one. All right. Negative 4.5x is greater than negative 21. So first step, plug in the value. We're checking the same value. Okay. Now, I mean, right away, if you're doing something that you didn't have to show work, you'd be, oh, negative times negatives is positive. Positives are bigger than negatives. Yes. But let's show our work. Now, I don't know how comfortable you guys feel doing 4 times 4.5 in your head, but I like to multiply decimals vertically. 4 times 5 is 20, carry the 2. 4 times 4 is 16, add the 2 is 18. However many decimal places it takes to go all the way to the right. Both of these, I come all the way back from the left. So it's going to be 18.0, 18, greater than negative 21. Is 18 greater than negative 21? Yeah, all positives are always greater than negatives, bigger. So that's the kind of work you need to show on your assignments to get credit for problems like that. Number 3, graph inequalities. So we're just going to graph inequalities. Okay. So I'm giving you the inequality, and you're gonna graph it on a number line. So we're going to draw a number line. I don't need you to write a ton of numbers, so just pick some ones that make sense, at least that number. So that's our number line. So then we're going to put a dot at where this, we're going to show the answers on this. It's going to be a whole chunk of answers. Lots of numbers are less than or equal to negative 3. So I want to show all of them. So it's going to be a dot at negative 3, but because it's or equals to, it's going to be a solid dot because that means we can use it. If it's an open dot, it's really just kind of the edge boundary of answers and we can't use it. Now, I always like to do this. Make the line darker and thicker. Make a darker arrow here to show that these are my answers. Now, sometimes some teachers would have you do this so that it kind of stands off the number line so you can see it either. I don't care. I mean, you're gonna have to see how the book presents the answers. Either of those are fine for me right now. Now, I'd say that usually it's easier if variable is on the left-hand side. Now I'll show you why. So here, I would flip this around. And you can flip it around, but the symbol has to get flipped too. So whatever it's opening up towards, it still needs to open up towards that. And so then I would say, okay, 0, 2, negative 2. I'm going to put a dot at 2, but an open dot because we can't use 2 as the answer. It has to be greater than 2. It can't be equal to 2. So this is just kind of an edge of where my answers are. And greater than is to the right. Now, greater than is always to the right. When something is greater than, bigger numbers are to the right, smaller numbers to the left of the number line. But there is a trick. This arrow right here is pointing in the direction that you want to shade or put your answer, right? See this? See, it's pointing that way. As long as the variable is on the left-hand side, that trick will work. Okay, last one, x is greater than 0. So we're going to do a number line, 0, I don't know, pick some numbers. I don't need tons of numbers, okay? I don't want you to spend tons of time making a very detailed line. Okay, so it's going to be open dot at 0 because we can't use 0. It doesn't say or equal to. It has to be bigger than 0. So the bigger than 0 could be like 0.0001. It could be a tiny number. It doesn't have to be like a nice integer. So it's either like that or like that, but you'll notice that the arrow is pointing that direction, telling you which way to go. Now, so the whole open solid dot thing, we could go up here to the top and say, okay, is less than, that's going to be an open dot. Okay. Greater than open dot, can't use it. Is less than or equal to, well, then we can use that dot. So we fill it in. And we can fill it in here. Okay. You're going to add those to your notes. Now, today's assignment, you're going to do the monitoring progress. Now, you need to upload your notes. They need to be all complete like this to get credit. Okay. Upload your notes today. Monitoring progress, page 54, number 1 through 11, all. There's little blue buttons that'll show you videos, how to do the problems if you have trouble, but these are the only two things you need to upload today, the notes and monitoring progress. I'll be available for help, but there you go.